Hey guys, so today we're going to be learning about a really useful statistics concept called the empirical rule. My name is Juan Carbajal. That's how you spell it. There you go. So just a bit of background before we get started. We can't have the empirical rule without the standard deviation, and we have Carl Pearson, the famous mathematician, to thank for discovering it in 1894. Alright, so our first step is going to be to define it. First off, it's also known as the 68, 95, 99.7 rule, and later on we'll apply these to normal graphs. So the textbook definition is, in a normal distribution with mean mu and standard deviation sigma, approximately 68% of the observations fall within 1 sigma of the mean u. 95% fall within 2 sigma of the mean u, and then 99.7% fall within 3 sigma of the mean u. So I know this is all really not making sense yet, and we're going to get to an example and what it looks like. So I went ahead and started to draw the graph. This is what most normal curves are going to look like. Oh, and an important note. This rule will only work with normal curves. If the curve isn't normal, then that means it will not work out. So now that it's sketched out, I began to fill in and label the sections. The first standard deviation is 68%, like the rule says. The second standard deviation is going to be, hey, you guessed it, 95%. And can you tell me what the third one is? Yep, you're right, it's going to be 99.7%, just like the rule. So now that we know what it looks like and what it is, you may be asking, how does it help? So by knowing the three numbers 68, 95, and 99.7, one can think about the normal distributions without having to make all the calculations. This is going to save you a lot of time and a lot of headaches. So now we can take all the things we've learned and put it into an example. The distributions of height for seniors from 10 Tech is 65 mean and 3 standard deviation. That's in inches. So A, what percent of heights are less than 59? And B, what percent of heights are between 62 and 68? So I went ahead and drew the graph, and for A, I'm filling in the section that we want to find. Now I'm applying the empirical rule, dividing it into its sections. We know the second one is 95%. Divide that, and that's 47.5. And now because we know each half is 50%, we can subtract 50% from the 47.5 to give us what we have left, and that's 2.5%. Then I went ahead and wrote that out in a sentence. Alright, done. Now let's go on to the next problem. So remember, we're looking for the percent between 62 and 68. My first step, just like my last problem, is to label the section I want. And hey, would you look at that, we already basically have it labeled. We know it's going to be 234%, which is going to give us 68%. So I went ahead and wrote that out in a sentence. See how simple that was once we applied the empirical rule? You save a lot of time. This problem also shows that the empirical rule can be applied to real-world situations, just like how tall a student is. Alright, so lastly we're going to talk about relevance to my personal life, and that's my love for calculus. So these are notes I'm taking that you don't really need to know when applying the empirical rule, but I took them down for my own benefit. So the first standard deviation on a normal graph is also known as an inflection point. This is something you learn in calculus AB. It has to do with derivatives and double derivatives. Basically what it is it's an indication of where concavity changes, and it's a concept that I really enjoyed learning. and that's why I chose to teach the empirical rule today. So that's basically it. Thanks for watching, guys, and remember 68, 95, 99.7.